And we're gonna talk about multiplying with decimals. We've already done this, but we want to just get a little reviewing. So, when I'm multiplying problems with decimals, what do I need to be thinking about? This is the part where you answer. So when I multiply numbers that have decimals in them, for example, maybe it's 23 4/10 times, say, 12. What are some important things I need to think about as I'm doing this? One person. Thanks, Andres. Nice job. Good. And Brent, I recognized you, and I said both you and Andres, and I even talked about Kendall as some students that are really starting to take some risks lately. Good. Brent, go ahead. Okay, so Brent said we're counting how many places to the right of the decimal. She said behind the decimal, but to the right of the decimal. So the total number of places to the right of the decimal is what we're keeping in mind. Okay? Now this isn't the correct answer, but let's pretend that the answer was 256. Oh, I did it, didn't I? 256. 2,564. What would our answer be in this case? Where would that decimal place go? Emma?
Between the 6 and the 4.
Between the 6 and the 4. I just showed you a minute ago where it would go. Now, why not right between the, let's say, the 5 and the 6? Why not there? Melissa?
Because it's just like a 0. You bring it down.
Okay. Now, Melissa is saying, Melissa, were you saying that you do not bring the decimal down, or you do bring it down? Okay. Let's talk about what Melissa said. Go ahead and talk to your neighbor. In what operations do you take the decimal and just bring it down? Or bring it up in the case of division? So talk. Which operations do you do that? Which operations do you just take? You take the decimal and you just move it down right below where it's at.
What?
Multiply? You think multiply either? Which operations do you just move that place value down? Hey, how about adding? When we have adding, we have a decimal place like this. Do we bring that decimal right down? Yes, good. How about subtracting? If I have subtraction, I have 14 4/10, and I subtract 2 and 5/10. Do I just bring that decimal down?
Yes.
Yes. In fact, if I have a problem set up like 14 4/10, and I subtract 2 and I have a decimal here, I would, like, smoke coming out of my ears, become furious, because this place value and this place value, I need to move. I need to have a shift here, because you're not subtracting the right place values. Here's the ones place, here's the tenths. That's no good. Division. How about division? Do we just carry or move the decimal place up? I see a hand back there. Andres? You need to be loud and proud, my friend. Bring it up. So if I have a problem like 32 and 4/10, I'm dividing by a number, I just bring that decimal place right up. Absolutely. So in all these cases, these three, I'm going to give them smiley faces. Those three situations, or I should say scenarios, we just move the decimal place down, move it up. Multiplication's not that way. Okay? Multiplication, we have to count how many place values total are to the right of the decimal. Now here's the like $100 question. And sometimes to kids, money isn't everything. So here's like the question worth the 3x box. Okay? How does that work? Why do we do it this way? Kendall, you have some comments or thoughts?
Yeah, the flip camera is running out of batteries.
It's running out of batteries?
It's on red.
Take it all the way to red. Take it all the way until it shuts off.
Okay.
Alright, so here's where we're going to answer the question. Jacqueline has a lemonade stand. She has 18 cups of lemonade she sells a day. So in one day, sells 18. Second day, sells 18 again. So after 2 days, she sells a total of 36. Just some quick 18 times 18 is 36. Now, let's say after 10 days, how many is she going to sell?
180.
Well, 18. Anything times 10 is going to take it and do what? Move it up. I have a problem with some people right now playing Space Invasion. You're spacing out on me. Okay? Bring it back. So this was going to be 180. So what happens when I say 1.5? That's a big difference from 18 times 15. Brent. How about let's solve the 18 times 15 first? Would you all agree that 18 times 15 is a little bit difficult to understand? But could we do 18 times 20? 10 of them was 180. 20 of them is double it.
160.
Okay, hands would be a good thing to do here. So what would 20 of them be? If 10 of them is 180, double it, it would be 360. See the 180 here? See the 360? Now, where does 15 fall? 15 falls in between those two. Would you agree? Falls in between?
Yeah.
So somebody just give me a guess. What do you think it'd be? In fact, I see degrees here. 180, 360. There seems to be a circle involved that comes to mind. What do you think it'd be, Yvonne?
260.
260 seems like it'd be pretty close. 230 might be pretty close.
270.
270 might be pretty close. 290. 260. Any others?
280.
280. 285. Do I hear 285? Okay. The answer actually would be 270. Okay? 270 is going to be that halfway point between 180 and 360. It's like skateboarders. One turn around is 180. All the way around, 360. But if I go that and then that little bit more, it's at 270. Okay? So my answer is 270. Now let's talk about what this 1.5 does. The answer when you multiply this times this would be 270.
Why do you have to put a
Big difference though between 270 and 27. If I multiply times 1.5, I'm going to move down here and do that. How is the problem on the left and the problem on the right, how are these two problems different? How are these problems different? Go ahead. How are these different? 15, 1.5. The only difference is one of them has a point, a decimal point. But this one right here is 10 times as small as this one. And I always use 10 times. You're like, what do you mean 10 times? Every time my number goes up, it's 10 times as much. 2 goes to 20, 10 2s. 20 goes to 200, 10 20s. So every time I go up, it's 10 times as much. Every time I go down, it's 10 times as less. So this is 10 times as small. So my answer, which was 270 over here, is now